talk about the project, which is due at the end of week 14, which is where we're at. So this is the information, right? You'll be working on this project throughout the term. Technically, some of you are, some of you did not. The project consists of all the extra credits. I'll go through each one separately, but the general layout is this, and I do have, wherever the heck it is, where'd I put it? I have the project PDF. Where the heck did you go? Yo, hold on a second. I had it. Where'd it go? Where'd it go? PowerPoint. That's it. Okay. So this is your template. You're given this template, right? Download it, right? It's here. Download and use this template for your project. Okay. Now, change the file name to include your name, full details from the related extra credit, blah. So this is my template. It consists of, I'll probably add some slides to this, but it consists of 10 slides. You know, the first slide is your data, title, your name, abstract, sample set, how you found the sample set, what it looks like, frequency table. I think this was like extra credit 2. Extra credit 3 was your measures of center, 5-number summary, IQR, measures of variation, interpretation of that. Extra credit 6 was like, extra credit 4, sorry, was all that. Extra credit 5 was the 90% confidence interval. What does it mean? And then the last extra credit was the hypothesis test and conclusion based on the hypothesis test. So you're given the template and it's all organized for you. And like I said, I probably would add some stuff to this because I did like some of the like 5-number summaries. I saw some of my students put a histogram, put a box plot. That's nice to see because some of the description that they were telling me of, the box plot visualized that. So when I get to that, I'll show you how to do it. And the abstract I always suggested to do at the end because it's kind of like a gist of what you did in your project, what it tells you about your sample and things like that. So you're only going to be able to talk about results and overall gist of the situation after you do it. So slide 3. So the first 2 are, okay, slide 3, sample set. Now you have to find the sample. Write at least 2 quality sentences explaining what you did and how you did it so that any other person would be able to obtain the same results. Do not leave the instructions on your project. I've had some people send me extra credit and the instructions are there. Some of them answered the question and some of them didn't. Do not leave the instructions there. This is your project. I don't need to know the instructions and what you were asked to do because I know that. I need to know your part of it, right? So the instructions are on the slide, but don't leave them there. Okay. Extra credit 1 deals with creating the sample. All right. So extra credit 1, and you click on the link. This is what extra credit 1 says. You'll be working on this project, blah. The data sets that you're choosing from can be found from this link, and you have a bunch of data sets to choose from. I chose for this particular example, this one, 2015 average annual number of melanoma mortality. This is technically my population. I have to choose a sample from this population, and I'm going to have to select the sample systematically. It's a systematic sampling method, which deals with finding a starting point and selecting every nth. And I'm guided as to how I should do that. So here, on this extra credit 1 instruction thing, it says, whoops. I'm missing the information, huh? Oh, hold on. I had to click on something else. Go figure, huh? It says, semester product. Where is it? Hold on, let me find it for you because for some reason, this was extra credit 1. I think you have to go through the, yeah. you have to go through, I'm sorry, I forgot about this part. In order to get to the instructions, you have to go through the data sets to get the instructions as to how you're selecting it, okay? And there's a video right there too, as to how you do it, just for more reference, whatever you need, there's extra videos. So this is where I found the instructions as to how to create the data set, okay? Because it wasn't on this extra credit 1 slide. I had to click data sets for extra credit and the semester project, and then instructions, okay? In the instructions, this is where it's telling me what to do, okay? If you want to get your data sets, you click data sets, and then there's even an example, which I'll put here too, an example as to how you're collecting the data, how you're doing the systematic sample. So you have a lot of information to help you, okay? So I clicked on example, and it showed me an example as to how I'm going to do the systematic sample. Okay, so the data sets on the data set tab will be used for the extra credits in the semester project. Once you choose one of these, this is the data that you're using for the whole project. It's what you use for all your extra credit assignments if you did them. Okay, you're not changing it. When making your systematic sample, you will only work with the set you choose. If you need to start again from the beginning, do so. There's a detailed example and video in the example tab to help you create your sample. Okay, here's the example of how you're collecting your systematic sample. All right, so you will be using, let me write this down, your birth month number as your starting place and your birthday as your nth value. So my birthday is 5/6. My month is May. My day is 6. So May 6th. So I'm starting on column 5, and my nth value is 6. For example, if Quinn was born on June 23rd, they would use 6 for the value to start on and pick every 23rd from there. Let's go to this data. I'm going to start on column 5. Okay. Row 1. 19 is the first value in my list. And being that my birthday is 5/6, I'm going to pick every 6th. So from here, I'm going to go 1, 2, 3, 4, 5, 6. 69 is part of my sample. 1, 2, 3, 4, 5, 6. 100 is part of my sample. 1, 2, 3, 4, 5, 6. 64 is part. I'm not going to do all 35 values, but I'm going to keep going until I get to 35. I'll do a few more. 1, 2, 3, 4, 5, 6. 11. 1, 2, 3, 4, 5, 6. You might be seeing a pattern. I'm going to say probably I'm going to continue here and probably going to continue here. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's only 16 values, right? I'm going to write a few more of them just to use. I'm going to say ... but I'll use these just to show you how to calculate other stuff. I'm not going to use all 35. This is just for an example. If I get to the point where I'm at the end, so my last value was in column 11. I'm going to write this down. Column 11, row 8. I have to wrap around. You're going to hear this wrap around thing, right? So let's go back to the instructions. What do I do if I don't have enough? So if Quinn does not get the 35 required, but runs out of data, they will wrap around. So the last number used was 49 in this example, column 2, row 9. The next value would be in column 9, row 2. So they're just like switching these values. If I go back to my example, my last one was column 11, row 8. My next one, I'll put it in green, is going to start when I wrap around in column 8, row 11. So column 8, row 11. Now I don't have row 11. So what I told some students to do, if this were the situation, was to just continue. So if this were like, this happened with a few of you, where you ended in a situation where if you switched it, right, my next one is going to be column 8 and row 11. I don't have a row 11. If this happened to you, what I suggested was after 56, just keep counting every 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Just keep counting every, in my case, keep counting every nth for you until you get to 35. So if this didn't work, like it did in the example, because I suggest to follow the example, but if it trips you up, like it did with some of you who came to me, then you're just gonna have to keep going. And I think there's one of you where you just kept landing on the same values. So you just had repeated values, okay? It just happened. And so you didn't have a choice. That was just how you got your 35 values. So do what you can, okay? Until you get 35. I hope that makes sense.
Professor,
Yeah.
do you guys verify our birthdays, or can I pick an easy birthday where I'm not gonna have all this issues?
I'm not going and looking up your birthdays.
Oh, okay, good. Thank you.
I'm not going and looking up your birthday. So you could be like, hey, my birthday's on blah, blah, blah. Whatever works, okay?
January 2nd. January 2nd. That's mine.
Listen, not everybody better pick that. Don't pick that. I mean, the goal behind like doing it that way was basically to get different samples, right? For different samples. I'm gonna add 79, 19. I'm just gonna add a few of these. So I'll use these values. So I keep going until I get 35. Looking over extra credit, I saw a few people did not have 35 values. You have to have 35, okay? Keep going until you get that. All right, so that is technically, I mean, it doesn't matter extra credit now, but that is my, where's my slide? Where you at? Where you at? Where you at? That is my first slide. I have so many things open here. That's this. Write at least 2 quality sentences explaining what you did and how you did. Now, I would love to see for my students, right? I like to see everything. So you could show me your population, show me, you know, this, your table, show me the color coordinated stuff, which, and how you selected your sample. And then I want you to write out your sample from that population below it. Okay, so you know, you could put another slide if you need to. I don't care if you add slides. This is the minimum amount. Add slides if you need to. Say, you know, here's what I did. Here's my sample. But make sure that you list the sample. Some of you did not list the sample. List the sample. Write at least 2 quality sentences explaining what you did and how you did it, so that any other person would be able to obtain the same results. My birthday is May 6th. 5 is the month of May, 6 is the day. So I started in row 1, column 5. I counted every 6th data value. So my n is equal to 6. I continued to count every 6th until I got to the end and wrapped around to continue counting every 6th until I got to 35 data values. Here is my list. Okay. If you guys did this situation, my last value for my first wrap or my first set did not give me 35 values, so I had to use the wraparound method. So my last value was column whatever, row whatever, and thus I started on column whatever, row whatever to continue to count every 6th. So you're describing it such that if I'm reading it, I want to be able to go, okay, this is what she did or he did, counting. I can create the same list, the same sample that you got just by following your instructions, okay? So that is important for the first slide. And I'm just going to use, I'm not going to use all 35 values. I'm going to use this for any of the other stuff that they asked me to do, okay? So that's the first slide. That's, you know, sample set. Slide 4, frequency distribution. You want to create a frequency distribution table for your set, your sample. You're not using the population, right? I'm not using this whole set. I'm only using my sample that was systematically sampled from that. I'm using my sample, okay, to create the frequency distribution table. And we want to create, obviously, we need to create the classes, we need to create the frequency, and then we need to calculate relative frequencies. But there is a specific way that you are asked to find your classes. So this is important, okay? So obviously, you're going to put your table here when you do it, but you need to describe what you did and why you made choices you did for your distribution. What I want to see here is how you calculate, how you found your table. How did you find your classes? Okay, how did you find the classes? Obviously based on the instructions. How did you find the classes such that I could recreate the same frequency distribution table that you gave me based on how you described how you calculated your classes, your frequency, and your relative frequency. So again, here, I want to see your description such that I can recreate the table that you are telling me, you know, represents your data. So I'm gonna put my little data set here. If I can. This is my, oh God, come on, guys. Give me this data set. Hold on. I'm gonna use just this, okay? I don't have 35 values, but this is what I'm gonna use, okay? To create the frequency table. I might not do the whole frequency table either, just to give you an idea as how to create it, okay? Following these instructions. Using the systematic sample that you created for slide 3, create a frequency table. You will have 10 classes. Well, good, it's already set up for me. Choose your class width using this. Okay, max minus min. So let's assume this is my sample. Again, I don't have 35 values, but I'm not going to write 35 values. I'm taking the max. So let's start with this. I'm taking the maximum, which in this particular sample is 160, minus the minimum value, which in this case is 5. And I'm going to divide by 10 minus 1. We'll say 9. Okay, so I'll go to my calculator. 160. This is not too bad. Following instructions, minus 5 divided by 9 is giving me 17.22222, which I don't want to leave as a decimal. I always round up. I'm going to go to 18. Right? If you recall, finding your class width, we typically round up to the next whole number. Okay. I always round up. Your first class will start at your minimum. So where is the first class starting? I found my class width. My class width is 18. So each class should have 18 values within it, right? From lower to upper limit. To find where I start, my first class will start at my minimum, which was 5, minus, this should have like a 0. This is just saying half of your class width, minus half of my class width. Okay? This is actually an easy calculation, but I'm going to show it on the calculator. 5 minus, 0.5 times 18. -4. Okay, so I'm following instructions. If your first class start is negative, that's what I got. Start the first class at 0. My first lower class limit is 0. Since for the data set, negative values don't make sense. So cool. Did my stuff. I'm following the instructions. My first class is 0. Now, your second class will start at your first class plus your class width. That makes sense because the difference between each of the lower class limits should match your class width. So 0 plus 18 is 18. 18 plus 18 is 36. 36 plus 18 is 54. And then so on and so forth, right? Keep going all the way down. These are just my lower class limits. My upper class limits. Well, if this one starts at 18, this has to end at 17. If this one starts at 36, this has to end at 35. And if you notice, 17 plus 18 is 35. 35 plus 18 would be 53. Blah, 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 blah. Okay, and so on and so forth. Keep that going until I get all the way to 10 classes. So you're on the lower limits, you're just adding 18. On the upper limits, you're just adding 18, or you could look at the value that starts here and go one less. So if you notice, each class, remember the class width is 18. Each class consists of 18 values because I'm including the endpoints. Okay, so even though 17 minus 0 is 17, because I'm including 0 and 17, there are actually 18 values in this interval. when you're describing your process, to find the lower class limit of the first class, I did my minimum minus half of my class width. Since my value was negative, I started my first class at 0. To find the lower class limit of the next class, I added my class width 18 and continued to do that to find all my lower class limits until I reached the last class. my upper class limit was found doing a similar method. My frequency. How do I determine frequency? Well, frequency is how much from the data set a value shows up in this class. So how many of my data values lie within this class? How many are between 0 and 17 inclusive? Do I have any? So I have 1. Let me use red. So I go through my data set and I count them. 1, and then I think just 2. Only 2 data values from my data set that are in this interval. How many are in 18 to 35? So let's see. 1, 2, 3. 3. How many are within 36 to 53? None. Looks like none. 0. Continue, blah, 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 blah. Verify the sum of my frequency of my frequency column should be 35 values because there's 35 values in my data set. So if this does not add up to 35, you made an error in one of your frequencies. So that's a quick verification. You could put this on your project too to show understanding. Relative frequency. You take each frequency and you divide by the total, which in this case, in every case is 35, and 2 out of 35, whatever that is 0. So let's see, how do I want to round? Probably going to go with maybe 3 digits to the right of the decimal, 0.057. 0.057 is my first relative frequency. My second relative frequency is 3 out of 35. I'm going to round to 3 decimals again, 0.086. 0.086. 0 out of 35 is 0. Blah, 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 until I get to the bottom where the sum of my relative frequency should be equal to 1 or extremely close to 1. 0.99 is okay. 1.01 is okay. If you're further than that, then maybe you made an error in one of these. Maybe you made an error rounding. Double check. Complete the frequencies table. Explain what you did. How did you find your class width? Yeah.
For the relative frequency, I keep getting 0.97. Is that okay?
Yeah, that's pretty close. I'd probably go. Did you check to make sure your rounding wasn't off?
Yeah, I didn't. I did it to 3, and then I did it to 4, and then I just kept playing with it. And the closest I got, I think I did get like 1.01. Is that better?
So it's just rounding. That's probably, it's closer. It's a rounding thing. Because you want it to be as close to 1 as possible.
Okay, thank you.
Any other? Yeah, no problem. I see you, Victoria. Okay. All right, so this was slide 4. Describe what you did. How did you find your class width? How did you find your classes? How did you find your lower class limits? How did you find your upper class limits? How did you find your frequencies? How did you find your relative frequencies? Explain it. And again, like I said, if you need 2 slides for space, whatever works. I don't care. Personally. Slide 5, measures of center. List your mean, median, mode, and describe what they tell you about your data, not the definitions. How balanced is your data? Are there a lot of one number or another? Now, I had some people keep this in here. I don't want to see this in here. I don't want to see the instructions. Let's go to that one. And this was extra credit 3. So basically, and I'm going to do all this in one shot because measures of the center, 5-number summary, and measures of variation can all technically be found in the same process. Can all be found in the same place in your calculator, okay? So I'm going to do all of that in one shot. So basically, I'm dealing with 3 slides in one shot. Not interpreting, but finding those values. So I'm going to use this same little set. I think I'm missing some numbers. Let me go get those. These, right? Can I fit them? Cool. All right, so now let's find all this. Measures of center, measures of variation. No, okay, hold on. It's not letting me do what I want to do as quickly as I normally would. Okay, so slide 7, mean, median, mode. Cool. Slide 7. Mean, X bar. Median, mode. Okay. So let's do it. And actually, I might as well write this down. 5-number summary, IQR, slide, that's SLIDE 8. 5-number summary is min, Q1, Q2, Q3, max. I don't, IQR is Q3 minus Q1, which I'll find. I'm gonna do all this with one calculator trick. Slide what is slide 6, slide 7. Why did I do this? Slide 5, slide 6. That's kind of funny. Why did I jump the gun? Slide 7, measures of variation, standard deviation and variance. Sample standard deviation is S. Variance is S squared. So all of this, like I said, can be found in the same calculator trick. So I need to input my data into my calculator because I'm going to use my calculator for it. Some of you did this already, stat and edit. If you guys started this from before, I told you to like put it in L5 because you were using the same sample for the whole semester. So if you were doing your extra credits, I was like, stick your 35 values in L5 so you don't have to keep doing that. And then you can come back to L5. But now, I guess once the project's done, it's done. You could put it in L1. So I'm just going to put these in 19, 69, 69, 100, 64, right? So I'm just sticking them in here. 11, 155, 160, 85, 79, 35 values. 19, 25. Make sure you put them right. And then, at the end of this, it should say L1 or whatever. It should say 36 because you should have 35 values in it and be on the 36th one. That's what this means. So I put mine in L1. So second quit. This is way back in the day. Stat, calc, 1 var stats is going to give me all of this. My list was L1, so second one to put L1. Frequency list, I don't need that because it's not coming from the frequency table. I'm using my original data, my original sample. Here's everything. X bar, my mean. I'm gonna go maybe 2 digits to the right of the decimal. 65.92. That's gonna be 65.92. S, X, my sample standard deviation because it's dealing from a sample size, 53.34. Put that here, 53.34. All the other stuff I'll find as I go. Scroll down, and I have my 5-number summary. My min is 5. Let's write that down. My Q1 is 19. My Q2, which is the same as the median, 66.5. I'm gonna write that here too, 66.5. My Q3 is 92.5. And my maximum is 160. Really, all that's left is my mode, my variance, and my IQR. All that's going to come from what I just did. My IQR is Q3 minus Q1. So Q3 was 92.5 minus Q1, which is 19. I could do that on my calculator. 92.5 minus 19. 73.5 is my IQR. My variance is my sample standard deviation, 53.34. I probably would take more digits, but I already deleted it. So to the second power, 2845.16. 2845.16 approximately, right? These are all the values. And my mode is really just the most repeated. You can technically look at it and determine that too. I think I just have one mode for this because 19 is repeated twice. So 19 would be my mode. Which value is repeated the most? Now, after you find all this, right? You're asked to describe what it tells you about your data, not the definitions. That is stated for a reason. Some of you said, well, a mean is this, the standard deviation is no. What does it tell you, the values that you got about your data? So you could do a couple of things. There are actually a lot of things you could do with this. You could talk about, this is something we didn't necessarily do here, but the range rule of thumb deals with like typical or usual values. You can find the typical or usual values actually corresponding to the empirical rule. Well, can't use the empirical rule because I don't know if it's normally distributed. We can actually look at that. But usual values lie within 2 standard deviations of the mean. Excuse me. So you can take your mean and subtract 2 standard deviations. And take your mean and add 2 standard deviations to find typical outcomes for your scenario. That's one thing you could talk about. Something else is the distribution, which you can actually, let's go back to the calculator. You can give me a histogram, a box plot. A box plot is nice with the 5-number summary because it'll show the distribution and basically some of the stuff that you say. Some of you are telling me skewness, which is cool. You could determine skewness based on the box plot and based on comparing the mean and the median and the mode. Is it skewed to the right? Is it skewed to the left? Is it normally distributed? To find your box plot, if you want to use a box plot, you go to stat plot, so second and y equals. You can go to the first plot. Mine is on if yours is not on. If your off is highlighted, then you want to scroll to on and press enter so it's on. There are 2 kinds of box plots that you guys can do. You can, and this would actually go along with some of the explanation that you can give. You could talk about distribution, you could talk about outliers. So let me show you. If I do the regular box plot, which is this one, and my X list is in L1, I'm going to go to graph. It probably won't show up. Oh, it does. If it doesn't show up, the reason is because, here's my list of values. The reason is because my window does not support the min and the max X value that corresponds to this. Like I need to be able to show these numbers. My minimum is 5 and my max is 160. So my X min should be a value that is less than the minimum from my list. And my X max should be bigger than the maximum value from my list, which mine happens to be because I did something else that yours probably won't have that. So make sure you change your window so you can see your box plot. From the box plot, you can talk about skewness. And this is part of your explanation. You know, comparing the mean and the median and the mode, we can determine that I have a slight skewedness or whatever, slightly skewed to the right. So if you have like a long right tail here or long right whisker, you say it's skewed to the right, positively skewed. The bulk of the data are lower values and maybe you have a couple high ones that are pulling it to the right. Same thing with skewed to the left. You have a couple low values pulling it to the left. Maybe it's normally distributed. I don't know. You're going to get different box plots. You can also determine, go back to stat plot, go back to my first plot. My modified box plot is going to show me outliers if I have any. So my modified box plot does not show me that I have any outliers. So this is part of what you can talk about with these slides as well, or with the slide, I should say. Your 5-number summary. Describe what they tell you about your data. So you can calculate your min and max value that's not an outlier, 1.5 times the IQR. And you can say, well, these values are outliers, or I have no outliers, or the modified box plot shows there are no outliers. your standard deviation, if it's large compared to your situation, my standard deviation here is 53. You know, based on your standard deviation, if it's big or small, larger standard deviations tell you that you have more variability, like the values within your data set are more spread and further away from the mean. If the standard deviation is smaller, they're closer to the mean. You know, these are things that you can talk about on these slides. You can add to it as you go, you know. Anyway, the average, what was the data set? The average annual number. So my average from my sample was, where was it? 65.92. You know, what does that mean? You know, on average, I have 65.92, whatever it was, I keep forgetting. Average annual, you know, melanoma mortality in 2015. So, and then, like I said, you know, if you want to add some more and do some research, you know, how to, you know, determine, you know, what values for a mean and a standard deviation indicate for a situation. Again, you are not telling us what a mean is. You're not telling us the definition of a standard deviation. You're telling us what your values are indicating for your situation. That's a big deal for these slides. Okay. If you need to go back to, you know, the stuff in Newton for those particular topics, look at the textbook and see what they did in terms of interpreting standard deviations and such. Okay. Last couple of slides is a confidence interval and a hypothesis test. So once you have your data in your calculator, this is easy. You want to find a 90% confidence interval. What does this tell you about your data? Why do you have to use a student t-distribution? You guys are using a student t-distribution because of the fact that you don't know the population standard deviation. You don't know it, so you have to do t, and that's the reason. And if you recall, when you're finding a population, I'm sorry, a confidence interval for a population mean, you go and you're using t-test, stat, t-test, I'm sorry, t-interval, I'm doing a confidence interval, interval for interval, t-interval. I would have data because I have my list in my data. I have it already listed in my calculator. Frequency 1, my confidence level is 90%, so 0.9. My calculator does it all for me. Here's my confidence interval. You guys can screenshot stuff too from your calculator. I would personally like to see you guys showing a 90% confidence interval in interval notation. I like to see that you know the notation that you have. Interval notation 38.26 to 93.57, and then try inequality form mu is less than 38.26, which is less than. These both are the same, but there's two different representations of this confidence interval. So you're showing me interval notation, you're showing me try inequality form, you're showing me that you know stuff, right? And then, you know, what is the interpretation? What does it tell you? This is coming from what you guys did over and over in your confidence intervals. We are 90% confident that the true mean mortality, I think it was mortality. What was it that I picked again? The true mean annual number of melanoma mortality. The true mean annual number of melanoma mortality. Number of melanoma mortality is between, or in the year, I should say, in the year 2015, is between 38.26 and 93.57. Right, this stuff comes directly from what we did with confidence intervals. You can go back to those, portions and see how to interpret a confidence interval. Okay, that's technically slide 8. 9 and 10 are your hypothesis tests. So hypothesis testing, you need this table, which is given to you to determine your hypothesis test. Now I chose, my population was this one, 2015 average annual melanoma number, right? That's the one I picked. So this is my number that I'm using on my null and my alternative hypothesis. So this is given to me. Choose your null and alternative hypothesis based on your first initial. My first initial is J, so J is between I through P, so I have a right-tailed test. See that? So I go to this and I'm like, well, this is gone. Oh, I can't edit this. I don't have it where I can edit it, but this first one is gone. Don't have that here. Don't have that in your project, because that's not your null and alternative. Get rid of this stuff, right? Give me your null and alternative hypothesis based on your situation. My null, my alternative hypothesis, is that mu is greater than my number 89, which is coming from this table. And my null could be equal to 89, or as it states, less than or equal to, right? Because the null always has the equal to portion. I want my test statistic, which is a t-score. I want my p-value. Excuse me. T-score, p-value, that's what this is. My test statistic is a t-score equal to, my p-value is equal to, how do I find a test statistic and a p-value? I go into stat, test, and I'm going to use t-test, because again, the population standard deviation is unknown, and I'm doing a test for a mean. T-test, my data is in my calculator in L1. My mu naught is the 89 that I got from this table. Frequency 1. Mine's a right-tailed test. This is going to vary dependent on your first initial. And this is my outcome, right? So, I mean, you could technically, if you want, you could put this, on your, what do you call it, on your project if you want. At least for me, I don't mind, but you need to at least tell me that you know what these values are, right? You're not just sticking it there. You're telling me, well, the test statistic, which is the t-value, is negative 1.499. My p-value is approximately 0.918. Ooh, this is gonna round up to 0.919, which is huge. That's huge. I'm given my alpha is 0.05, right? So this is an easy slide, but now conclusion. Based on the information provided, should the null hypothesis be rejected or not? Include why? What conclusions can be drawn? Okay, so whatever method you want to use, you're not required to use the traditional method. If you want to give me a critical value, I would love that, because that shows more understanding of hypothesis testing. You're not asked for it, so it's not required, but if you want to, that would add to showing understanding. But you could use the p-value method, and you can say, well, my p-value is way bigger than my alpha. Using the p-value method, I can see my p-value is greater than alpha, and thus we reject the null hypothesis. Write it out, And therefore, if I'm rejecting the null hypothesis, I'm supporting the alternative, I'm going to write, this is all standard stuff. Standard, repetitive stuff that you've done. There is sufficient evidence to support the claim or the alternative that the average, and actually, I'm going to probably copy and paste that the true mean average, I'm going to take that and use it again. That the true mean average annual in the year 25 is less than 89. Oh no, sorry, mine's a right tail. Greater than. This is my last slide. So that's what we're at. Don't write this instruction. That's what we're asking for. This is basically stuff that you did within Newton to indicate, yeah, you guys know what you're talking about, right? Then you can go back to your abstract and say, hey, you know, we looked at the population of 2015 average annual number of melanoma. We gathered some statistical values. We indicated that that there might be large variability based on the standard deviation or whatever. You can compare, I forgot what my average was. You know, you can say, you know, my average was 65.92. You know, my hypothesis test indicated that the average should be greater than. You can just talk about your situation. What does it tell you? And just as much as you can. That's it. And then you can, you know, clean this up so that it doesn't just look so plain. If you go to design on PowerPoint, you could pick a design that you like, pick colors that you like. You know, you can apply it to all. You can change the design of each one of the PowerPoint. You know, whatever. Make it look professional. You're doing a project, okay? So make it look nice. And then whatever. You guys should know how to clean that up. So let me stop recording.